So we're going to get started with literal equations. First, let's go and create a definition. So a literal equation is an equation that involves two or more variables. All right. So this is very similar in terms of steps to solving a one-step, two-step, multi-step equation. However, the difference is that we are solving just to create another formula because we're dealing with multiple variables. So we are no longer just solving to get x equals some numerical answer. We're actually going to be looking for a formula where like x equals 2y plus 5. Okay? So let's look at what that means. So we have our first example, 10x plus 5y equals 80. Solve the given equation for y. And here's where things are similar. So I'm going to draw my line. How I solve for it is the same steps as solving for your multi-step equations. So 10x plus 5y equals 80. And we are solving for y. That means I want to get y by itself. So in my mind, everything else is going to move except for the y variable. So I'm going to start off by moving the 10x by subtracting it on both sides. Those cancel out. This leaves me with 5y equals negative 10x and 80 are not like terms. One has a variable, the other does not. So I'm going to put negative 10x plus 80. Okay? Now we have 5 times y equals negative 10x plus 80. And remember, we want to get y by itself. So I'm going to have to go and divide by 5 and for each term, okay, on both sides of the equal sign. These cancel out. I'm left with y equals negative 10x divided by 5 is negative 2x. And then 80 divided by 5 is 16. That is my equation. Okay, that's what I'm solving for. So I solve for y. I know what the value for y is. Y is negative 2x plus 16. Okay, that's the only thing I can do, especially when you're dealing with two variables. That's all you can do right now. So I solved it. Now I have a formula for it, and so I'm done. Okay, let's go and try our next one. Negative 2x plus 5y equals 12. Okay, so again, still solving for y. So I'm going to go and move all my variables except for the y one. I'm going to leave it where it's at. That cancels out. I'm left with 5y equals a positive 2x plus 12. So once again, I have 5 times y equals 2x plus 12. Remember, 2x and 12 aren't like terms, so I just have to put them together just like that. So I have 5 times y. So I want to do the opposite, and I want to divide by 5 for each term that I see in the equation. This will cancel out. I'll have y equals. Now, in algebra, we want to go and keep unless your answer choice tells you want to go and keep your answer choices as fractions, okay? Especially if they're simplified. As long as they're simplified, you can leave them unless you're questioned based on your answer choice or what you need to fill in, if it's agreeable or not. You can go and leave them as fractions. So 2/5 is simplified. So I'm just going to leave 2/5 x. 12/5 is as simple as it's going to get. I'm going to put plus 12/5. And that's your answer. You have a formula for y. Okay? So now we're going to keep going with our examples. We're still solving for y. And we're going to go look down here at the bottom. So I have 4 equals 2y minus 5x. Y is on the other side. It doesn't matter. It doesn't matter. you're still doing the same steps. So I want to get y by itself, so everything else needs to move. So I have negative 5x on the right. I'm going to add 5x to both sides of the equal sign. So I get 4 plus 5x equals, that canceled out, and I'm left with just 2y over here. Okay? Now I want that 2 off of the y. It's 2 times y. I want y completely by itself. So I'm going to divide everything by 2. 4 divided by 2 is 2. 5 over 2 is as simple as it's going to get, so that's plus 5/2 x equals, these canceled out to y. Now, this is your answer, okay? 2 plus 5/2 x equals y. If you're a person that needs to have this equation rewritten, you can. So that's your answer. You can also go and write it as y equals 5/2 x plus 2. These are the same. So you rewrite if you need it, or if your answer choice has it rewritten and you want to go and make sure you match up, you can do that. But 2 plus 5/2 x equals y is the same as y equals 5/2 x plus 2. All right, so on to the next one. X minus 2y equals negative 10. We're still solving for y. I want y by itself. So I'm going to move the x. If you want to put a 1 in front of the x, you can. Or if you just understand that there's a 1 there, you don't have to. I'm not going to put 1 this time, so we can see all things. So that would cancel out. I have a negative 2y equals a negative x minus 10. And once again, I have that negative 2, okay, that is attached to the y. And so I want to go and get that off of there. But I have to divide it by every term in the equation. These cancel out. I have y equals negative x divided by negative 2 is a positive x over 2. Negative 10 divided by negative 2 is a positive 5. Okay? There goes your answer. You solve for y. You can't do anything else. Now, another way this can be written, okay, or it could be y equals, now remember with that x, okay, there's a 1 there that we can't see. It can be 1/2 x, okay, plus 5. So keep in mind about that, about the 1, okay, that's present, even though you can't see it. Just in case your answer choice switches up. But x over 2 and 1/2, those are the same things, okay? Now we're going to look here, and we're going to change things up. We were dealing with y, where we had coefficients and we had variables. This time we're going to work only with variables. So only with the letters, only with variables. Okay? And in this case, we are going to solve for x. And we have ax plus by equals c. So that means I want to get x by itself. And you go and you find what's the easiest thing to move. And for me, it is the by. So I'm going to add by to both sides. Okay? I'm left with ax equals by plus c. And I'm going to move this over here so I have more room to work with. Ax equals by plus c. Okay? Now I go back and I look. I have a times x equals by plus c. I'm solving for x, so I need that a to go away by doing the opposite operation. So I'm going to divide by a on both sides of my equal sign for every term. So I have x equals by divided by a plus c divided by a. Okay? Or we can go and do a quicker thing where we'd have x equals by plus c and I can go and divide the whole term by a. But I'm understanding that by is divided by a and c is divided by a. So either one of those will go and give you the correct answer. And written both ways, those are both algebraically correct. All right, let's do some more. So we have another one. This time we are solving for y. We have negative x equals r plus p times y. So our first thing we're going to do is we want to get y by itself. So you're going to move the easiest thing. What is the easiest thing to move? And in this case, it's the r. It's a positive r, so I'm just going to subtract r on both sides of the equal sign. So over here I have negative x minus r equals py. I'm going to rewrite that over here. All right. Okay, we're still working. So now I'm solving for y, so I want y by itself. And I think, how is p attached to the y mathematically? Through multiplication. So I have to do the opposite, and I have to divide by p. And everything over here has to be divided by p, negative x and negative r. When I do that, I come out with negative x minus r divided by p equals this canceled out to y. All right, and I solve for y. If you are a person that needs it rewritten, it would be y equals negative x minus r divided by p. Or you could divide each term by it if you needed it, but this keeps it simple. So once again, these are the same. All right. So now we're going to look at literal equations in terms of formulas. And this is good when you are dealing, with science or, anything in algebra, where you are looking for something from a formula, but it's not based on the original formula. Okay? And I'll go and explain what that means after we go and get a definition for formula. Okay, so what are formulas? Let me go and create a little space here. Okay, a special type of equation that shows the relationship between different variables. All right, so if we look here in this box, these are all examples of formulas. Perimeter, area, distance, temperature. Okay, when you're doing your temperature conversions from Celsius to Fahrenheit or vice versa. These are all examples of formulas, okay? Now, with these formulas, they are solving for something. So if we look at perimeter, the formula is 2 times the length plus 2 times the width. But why you would need literal equations is that, let's say you were looking this time, you were given the perimeter, you were given the width, and you wanted to know what the length is. The formula would be different, okay? It would look different. And so now on this part, we're going to be going and rewriting equations so that we can rewrite an equation to solve for one of the variables in a formula. All right. So if we solve for each given variable, we have circumference equals 2 pi, and we are going to solve for r, okay? We're solving for r. Steps are all the same. All right, so circumference equals 2 times pi times r. Listen again. Circumference equals 2 times pi times r. So, if you notice, everything was multiplication there. So in order to get r by itself, I have to divide by everything. So I can make this a bit of a one-step, where to get r by itself, I would have to divide by 2 pi, and I would do that on the other side. 2 pi. All right. C equals, so that canceled out, and R was left by itself. C divided by 2 pi equals R. Or if you need it rewritten, R equals C divided by 2 pi. We got R by itself rather quickly, okay? All right, let's look at our next one. We have area equals 1/2 the base times the height. Solve for H. All right, we're solving for H. Go and do that. Now, when you have a fraction, you want to try to get that fraction out of your equation or out of your way as soon as possible. So because it's 1/2 and the numerator is 1, I can go and make this easy for myself. And I can go and get rid of this because that's all multiplication. Again, 1/2 times base times height. When you're dealing with the fraction, you're going to multiply by the opposite reciprocal. So I can multiply both sides by 2/1 if I want it. But remember, 2 divided by 1 just simplifies to 2. So that will leave me with 2a over here equals, these canceled out, and I have bh. And I'm solving for h. And now how is b attached to the h? Okay? Through multiplication, so I have to do the opposite, which is division. So 2a divided by b equals h, or h equals 2a divided by b, if you need it rewritten. Okay? So you're probably wondering, well, that was a fraction, so why didn't we just go and do like we did on the previous example and just divide them all together? But remember, when you are dividing by a fraction, you are multiplying by the reciprocal. So technically it's a different math operation, even though it's all about division. All right, so another quick one. We have distance equals your rate times time. We're going to solve for time. So this one is pretty straightforward. I need to get t by itself, and that's r times t. So I'm just going to divide by r. And I have d divided by r equals t. And I solve for t. Very simple. Remember, if you need it rewritten, t equals distance divided by your rate. Okay? All right, now over here we have Celsius equals 5/9 Fahrenheit minus 32. Okay? And we are solving for Fahrenheit. So we're going to go and convert back to Fahrenheit. Okay? So the first thing you want to do when you see a fraction is you want to go and get rid of it if possible, so you don't have to go and manipulate it anymore. In this case, we're not going to be able to completely get rid of this fraction, but I can get it out of my way quickly. So it has 5/9 times f minus 32. So in order to get rid of it, I need to multiply, or I need to actually divide that fraction, which means multiplying by the reciprocal. So I'm going to multiply this side by 9/5 and this side by 9/5. So now here on the left, I have 9/5 times c, because they're not like terms, so I can only show that they're multiplied. Now, when you saw that, you probably were like, oh, I know what to do. I'm going to go and distribute and do this and do that. You don't need to distribute because, remember, we're only rewriting the formula, okay? But me multiplying by that reciprocal allowed the parentheses to go away over here. So now I don't have to deal with anything distributed because I went and moved that fraction over. All right, now I want to get f by itself. So the only thing that's now attached to f is minus 32. So I'm going to add 32 to both sides of the equal sign. Now I wind up with 9/5 c plus 32 equals f. And that's my formula. And remember, as always, if you need to go and rewrite it, F equals 9/5 C plus 32. Those mean the same thing. And that's all literal equation is. You're going and solving for a variable that they tell you to solve for, and you are using the same steps and methods as you would do solving any type of two-step or multi-step equation.